In this module, we'll look at solving trig equations, or equations that involve trig functions. The biggest thing to remember with solving trig equations is that the trig functions in general are not one-to-one functions, which means that as we're solving these equations, there is very possibly going to be more than one answer for x as we go through and do this work. So even though our calculator may only give us one answer, we're still going to have to know enough about trig functions to double check to make sure that there are not multiple answers. A good example of this type of equation would be solving the following. Sine of x equals 1/2. Now, on the surface, this looks like a pretty simple one to solve because from an earlier module, it's been discussed that if we want to undo the sine function, we can take the inverse sine of both sides. The sine and the inverse sine functions undo each other, and so we end up with x equals the inverse sine of 1/2. Now the question is, what value of x gives an answer of 1/2? And if we use our calculator, or if we think back to the graphs, one of the solutions we're going to come up with is 30 degrees or pi over 6. This seems like a good answer, seems like we should be finished, but most of the time when we're working with trig equations, the condition is either literally written out or even understood to be that we're looking for all the solutions between 0 and 2 pi, or between 0 and 360 degrees. So even though pi over 6 is a good solution, we have to also decide, are there other solutions? And if we think back to the graph of the sine function, it looks like this between 0 and 2 pi. And if we're trying to decide how many places does this graph equal 1/2, if we come in and draw where y equals 1/2 is located, we can clearly see that there are two solutions to this equation. We've already found the first one through the algebra. It's pi over 6. Where is the second one at? Well, notice that the middle point of the sine wave is pi, or 180 degrees, so that if I need to go forward pi over 6 to get to the first solution, I need to go backwards pi over 6 from pi to get the second solution. And so my second solution is pi minus pi over 6, which is the same thing as 5 pi over 6. So in this case there are two solutions. There's one in the first quadrant and one in the second quadrant, and they are pi over 6 or 30 degrees, and then 5 pi over 6 or 150 degrees. Another example that we can look at, what if the equation is the cosine squared of some value plus 1 equals 2? Just like in any other algebra equation, we try to isolate the variable x, and so step 1 is just subtract 1 from both sides so that the cosine squared of x is equal to 1. Now the next step is we can try to get rid of the squared function by square rooting both sides. So the cosine of x equals 1 or negative 1. At this point we can set up two separate functions. We can say, where does the cosine of x equal 1? And where does the cosine of x equal negative 1? So we're looking for, where does the cosine or the x-coordinate have a value of 1? And that would take place at 0 degrees or 0 radians. Where does the cosine have a value of negative 1? Well, that would be on the other side of the graph at pi. So the solutions would be 0 and pi. It's possible that we could also include 2 pi in here, but since 0 and 2 pi are both at the same location on the graph, we really don't have to include both of those in our solution set. I'll go through one more example with you before I give you a chance to practice some on your own. Third equation let's look at is, what if we have instead of a sine or a cosine function, what if we have something like the secant squared equals 2? Now, for this problem, it might be easiest to invert this back to either a sine or cosine. In this case, secant is 1 over cosine, so we can think about this being equivalent to 1 over cosine squared equals 2. Or, if I want to take the reciprocal of both sides, I can say this is equivalent to the cosine squared equal to 1/2. Now, just like before, I can proceed by go ahead and taking the square root of both sides to get the cosine of x equals the square root of 1/2 plus or minus. And so now I have two equations. I need to find out where does the cosine of x equal the positive square root of 1/2, which is the square root of 2 over 2, or where does the cosine of x equal the negative square root of 1/2 or the square root of 2 over 2. Square root of 2 over 2's, those should come to mind as the ones that are 45-degree angles. And so where do we have this taking place? This would be at 45 degrees in the first quadrant. Or where else does the cosine of x have a positive value? Which other quadrant? Well, it should be in the fourth quadrant because the cosine is our x-coordinate. So 45 degrees is one solution, and the next solution would be at 360 minus 45 degrees, so that we're down in the fourth quadrant, and that would be 315 degrees. Where does the cosine of x equal the negative square root of 2 over 2? Those are actually going to be in quadrants 2 and 3, and so in this case, x will equal 135 degrees, and in the third quadrant, x would equal 225 degrees. So we actually have, starting at 45 degrees, when we put all these together, we have 45 degrees plus 90 degrees times some number k. 90 degrees times 1 gets us to 135. If we add on 90 degrees times 2, that gets us to 225. And then similarly for adding on 90 times 3 will get me to 315. So sometimes you might see the answer written in a form like this, where we see that 45 degrees is the starting answer, and then if we keep adding 90 degrees, we keep getting to another solution. At this time, you should try to solve the following problem on your own. 2 times the cosine of x equals 1. And you should pause the video, solve the problem, and when you think you've got the solution, go ahead and restart the video. Alright, to solve this problem, we would want to proceed just like we normally do in algebra. We want to isolate the variable x, and the way that we'll be able to do that is by dividing, first of all, by 2 on both sides to get the cosine of x equals 1/2. And at this point, we're looking for a function to undo the cosine, which is, of course, the inverse cosine. So our final solution here will be the inverse cosine of 1/2, or in other words, what angle measure gives us a cosine equal to 1/2. In this case, the final answer for x is pi over 3, or 60 degrees. And then we still want to go back and check to make sure there's not another solution out there somewhere. If we think about the cosine graph, it starts at a height of 1 and then decreases back down to pi, and then it increases back until it reaches its peak at 2 pi. If we think about the fact that we're looking for the cosine of x equal to 1/2, if we go pi over 3, we get to one solution, so that means we have to go backwards pi over 3 from 2 pi to get the other solution. So 2 pi minus pi over 3, which is equivalent to 5 pi over 3 as our other solution. So pi over 3 and 5 pi over 3 were the correct answers to this problem for all the solutions between 0 and 2 pi. The next example that I'd like to look at is a problem with trig functions on both sides. So what if we have the sine of x equals 2 times the sine of x times the cosine of x? Now it's very tempting to try to come in and just cancel a sine from both sides because we see there is a sine of x on both sides. But that would be incorrect. We would lose some of the solutions that are actually legitimate solutions. So what we want to try to do is move everything over to one side. Doesn't matter which side gets subtracted to the other. And go ahead and set this equal to 0. Now what we try to do is factor on the left-hand side and then look for our solution set. I can factor a sine of x out of both terms, and I have 1 minus 2 cosine of x left over. So now I have two possibilities. Either the sine of x can equal 0, which would make the left side 0 times something in parentheses, which would be 0, or I can have 1 minus 2 cosine of x. I could have the parentheses part be the 0 part, and then I would have the sine of x times 0, which would still be 0. Now I need to solve both of these equations. Well, where is the sine of x equal to 0? That occurs at 0 and pi. Second equation, 1 minus 2 cosine of x, that's very similar to the one I had you solve on the previous slide. I could add the 2 cosine of x to one side, divide both sides by 2, and I'm looking for where does the cosine of x equal to 1/2. And we decided on the last slide that occurred at pi over 3 and 5 pi over 3. So for this particular function, or this particular equation, we had 4 solutions between 0 and 2 pi. At this time, you should attempt to solve the following trig equation. Tangent squared of x plus the tangent of x is equal to 0. You should pause the video, try to solve this, and then hit play when you're ready to see if your solution is correct. Alright, an approach similar to the previous example, we want to try to factor from the left side, and I can take out a tangent of x from both terms. So now I'm looking to solve either the tangent of x equal to 0 or tangent of x plus 1 equal to 0, which then leads to the tangent of x equal to -1. So the points we're interested in, where does the tangent function equal 0? Those values are at 0 and pi. And where does the tangent of x equal -1? Those values occur at 3 pi over 4 and 7 pi over 4. So again, this problem had 4 solutions. All of them, when plugged back into the original equation, will make the left side turn into 0. Now, so far I've given you a bunch of equations where we've had nice solutions, either solutions dealing with 30, 60, 90 triangles or 45, 45, 90 triangles. But not all trig functions are going to work this way. So what if we have, for example, the following function: 4 times the sine of theta equal to 3. We want to solve this for theta. Initial step would still be the same as before. We'd divide both sides by 4. So sine of theta equals 3/4, and then take the inverse sine of both sides. So we're looking for the inverse sine of 3/4. Now this is not a nice answer, but you can get it by plugging it into your calculator. The inverse sine of 3/4, you might get a decimal answer, and in that case, if you want it in degrees, you may have to multiply by 180 over pi, but eventually you should end up with something in the neighborhood of around 48.6 degrees as the final answer. Thing is, though, we're not finished, because sine functions are not one-to-one, so therefore we may have more than one legitimate solution here. if we think about the fact that we're looking for the sine of theta to be a positive number, the sine of theta is positive in the first quadrant, which is the solution we already have, and it's also positive in the second quadrant. So if we're looking for that second solution and we're thinking about the sine wave and what it looks like, okay, the first quadrant solution was somewhere over here at about 48.6 degrees. The second solution is going to be coming back 48.6 degrees from 180 degrees. So our second solution is going to be at around 131.4 degrees. So both of these solutions are legitimate, but again, your calculator will only give you the first solution. You have to know enough about trig functions to come up with more solutions if they do exist. At this time, you should now solve the following equation on your own and then check your answer to see if it matches up with my solution. 3 times the cosine of theta plus 2 equals 7 times the cosine of theta plus 1. Solve this for theta and give all of the solutions between 0 and 360 degrees. Alright, the solution for this example, we again want to try to isolate the theta by combining all the like terms together. So I'm going to start by subtracting 1 from both sides and subtracting 3 cosine of theta from both sides. Then I'll divide by 4 and end up with cosine of theta equals 1/4. Now again, stopping to think about this, the cosine has a positive value in the first and fourth quadrants. So when we type in inverse cosine of 1/4 into our calculator, theta tells us that this answer, or the calculator tells us that this answer for theta is 1.32, which if we convert it to degrees is roughly 75.5 degrees. So either 1.32 radians or 75.5 degrees. Now again, this is not the only solution though. We've either got to recognize the fourth quadrant has another solution. So the solution in radians would be 2 pi minus 1.32, or if we're thinking about it in degrees, 360 degrees minus 75.5 degrees. And these would be your two answers after you go ahead and simplify them. I'll give one final example, and I'm not going to write the whole thing out, but I will write out the initial equation here. This is an application dealing with trig functions, and it has to do with the height of a projectile that's launched at a certain velocity and a certain angle into the air. And the equation that describes the relationship between all these things is h equals negative 16t squared plus v times t times the sine of theta. In this problem, h is the height of the object after t seconds. So t is the time component in seconds. The v is the velocity of the object as it was launched. And theta is the angle at which the object was launched above the ground when compared with the horizontal. So the question here that I'm going to pose is, find the angle theta if the initial velocity was 1500 feet per second and after 2 seconds the height of the object was 75 feet. And your job is to solve this for theta. Again, you should pause the video at this time. Now that the problem is set up, go ahead and try to solve this for theta, then come back and check your answer. Alright, after plugging in all the values, h we said was 75. Plug in 2 for t and then multiply that through, we end up with a negative 64 plus the initial velocity times t. So 1500 times 2, I'm going to go ahead and write that as 3000 right away as soon as I get the eraser. And then back to the pen. Times the sine of theta. Now we want to go through and add continuing on with the algebra, we would add 64 to both sides to get 139 equals 3000 times the sine of theta. Divide both sides by 3000. And I'm not very good at doing 139 divided by 3000 in my head, so I'm going to just leave it right here. But then once you have that answer, go ahead and take the inverse sine of that fraction, 139 over 3000. And what you should come up with is something in the neighborhood of 0.046. And again, this is in radians. So if you want to convert this to degrees, you could multiply by 180 over pi, and your final answer ends up being in the ballpark of around 2.66 degrees. So this makes a lot of sense, though. If we're shooting something off at an initial speed of 1500 feet per second, and after 2 seconds we're only at a height of 75 feet, that's not very high considering the velocity we're shooting this off with. The only way in order to make that happen would be to have a very low angle of elevation, and in this case we had that, only a 2-degree angle of elevation. This concludes the videos for solving trig equations. Again, a reminder, the biggest thing is that your calculator will only give you one answer on these types of problems, but it's your job to remember that usually we're interested in finding all the solutions between 0 and 2 pi, so you'll have to use your knowledge of trig to go ahead and find the remaining solutions once you have that initial solution.